So page 83 and question 7. 7 part A says, part I, calculate the average kinetic energy of the runner during this rate. So A part I, what's the kinetic energy of the runner? Well, kinetic energy equals half mv squared. We don't know the velocity, but we know velocity is distance over time, which is 5,000 over 15 minutes, 15 times 60 in seconds, which comes out as 5.56 meters per second. So we can work out the actual velocity from using distance over time, and then say kinetic energy is half mv squared, half times mass, which is 70 times the velocity squared, 5.56 squared, which comes out at an answer of 1082 joules. So there's the calculation for kinetic energy. Part 2, total loss in gravitational potential energy. So part 2 is total loss in gravitational potential energy, which is mass times gravity times height. Total loss in gravitational potential energy therefore is 70 times 9.81 times 520, which is 357,084 joules. And you notice that the gain in kinetic energy is just about over 1,000, but the loss in gravitational is about 350,000, so much more. There's a big difference there. Explain why the answers are not the same. Because the gravitational potential energy, some of it turns into kinetic, but most of it turns into work done against friction. So most of the gravitational is not turned into kinetic energy, but is turned into work done against friction. 7a part 2 and part 3. 7 part B then. State the principle of conservation of energy. In any process, the total energy before the process is equal to the total energy after the process. And part 2, use that principle to show that an object dropped through a vertical distance of 520 can have a speed of more than 100 meters per second. Well, the formula here is that GPE equals mgh, gravitational potential energy is that, and kinetic energy is half mv squared. And in this situation, in the ideal situation, all of the gravitational is turned into kinetic energy, so therefore mgh equals half mv squared. And we can do some cancelling here. The m's can cancel, and therefore we get gh equals half v squared, multiply that by 2, 2gh equals v squared. Put v squared on this side, v squared equals 2gh, and then take square root, v equals root 2gh. If we use that formula and we say something is falling through 520 meters, we can say that in fact v equals square root of 2 times 9.81 times 520, which comes out as in fact 101 meters per second. So if all of the gravitational is turned into kinetic and there's no work done against friction, which of course is highly unlikely, then the theoretical maximum speed that something can travel at is just over 100 meters per second, 101 meters per second.